At the end of this lecture, you should be able to clearly define the two phases in any TensorFlow program. TensorFlow is a very powerful numerical computation framework that was open sourced by Google in November 2015. Its representation of all computations as a directed acyclic graph makes it very suitable for machine learning applications, such as neural networks. In order to get an understanding of how TensorFlow works and how you would set up operations in TensorFlow, we'll start off with some very simple numerical computations. Simple math using TensorFlow constants. We are going to create a brand new data lab instance where we'll run our TensorFlow programs. But before that, let's set up some default configuration properties for our Google Cloud Platform account. We use the gcloud command line utilities to set these configuration properties. We want to set the default project to be my test project. That's the project we've been working on so far. We also set the default computation zone to be US Central 1F. From your Cloud Shell command line, you can use the Data Lab create command to set up a Data Lab VM instance. The code that we execute within this instance is temporary. We don't want to commit those code files to GitHub, which is why we can say no create repository as a command line argument to Data Lab create. And the last argument here is the name of your Data Lab instance. This is the name that we'll use to connect to Data Lab. This command will not exit on this terminal window. We simply use the web preview to connect to port 8081. This is the connection to our Data Lab instance. Once you have the browser pointed to your Data Lab instance, you can create a new folder where you'll store all your TensorFlow code files. So create a new folder called Learning TensorFlow. The source code for this demo and for the next few demos, maybe about 10 or 12 of them, should be available for you to download along with this lecture. You can also choose to download the source code from this short link. This is a Google Drive folder and it's publicly accessible to anyone. This source code is not a part of Google's Code Lab series and is not available on GitHub anywhere. Once you've downloaded the resources that are associated with the next few demos, you can unzip it and then upload it to this particular folder. Click on the upload button. I'm going to select all the Python notebook files that are present in the source code folder and I'll upload it to Data Lab. Let's start off with our very first TensorFlow code. Open up the Simple Math Python notebook. The TensorFlow libraries are available in a bunch of different languages: Python, Java, C++, and even Go. Of all these APIs, Python is the most stable and that is what is recommended for production systems. In the first code cell, we import TensorFlow as TF. It's very common to refer to TensorFlow as TF within your program, that's the short form. And we import the ML library from Google Data Lab. We then instantiate a whole bunch of constants, A, B, C, and D. This is simple scalar data here. It has just one value. Constants are essentially exactly what their name implies. These values cannot be changed over the course of this program. I've specified a scalar value for every constant and also associated a name with each of these constants. The name help identify these constants when you view the visualization of this computation graph on TensorBoard. We'll now perform some very simple math computations using the simple math functions that TensorFlow provides. The operations that we perform are add a plus b, subtract b minus c, and we square d. And each of these operations also have an associated name. The results of these operations then feed into final sum. Final sum adds up the result of add, subtract, and square. Any TensorFlow program that you work with, whether it's very complex neural networks or these simple math operations that you see on screen, they are executed in two phases. In the very first step, you build up the computation graph that you want to execute. At this point in our simple TensorFlow program, we've completed the very first step, building the computation graph. In this computation graph, the operations that we perform on the data, such as add, subtract, and square, these form the vertices, and the data that's operated on form the edges. In order to run this computation graph, we require the session object. This session object represents the environment in which these computation graphs are executed, which is why we set up a session using tf.session and store it in the ses variable. Within the session, we first compute the intermediate add, subtract, and square operations by calling session.run add, ses.run subtract, and ses.run square. And finally, we compute the final sum. Note that it's not required that we compute the intermediate value separately. You can call session.run on any node of the computation graph, and TensorFlow will compute all nodes which feed into that node. We also set up another calculation here, another sum which adds up A, B, C, D, the constants that we initialized, and square. This is also executed via session.run. And this forms the second step in any TensorFlow program. Once you build up the computation graph, you will then execute it or run it. One thing to ensure when you use a session variable is to close it when you're done with it. That is good practice, which is why generally session variables are instantiated using the with statement. A shift enter on this cell will print out the results to screen. Session.run has successfully executed the nodes in our computation graph. If you're working on a TensorFlow program of any level of complexity, you typically want to visualize the computation graph you've set up and see how data flows through it. You can do this using a very cool tool that TensorFlow provides, the Tensor Board. The way you use Tensor Board is by generating summaries of quantitative metrics within your program. You can also use it to display images. Using Tensor Board requires you to instrument your program to write out summaries. This we do by using the tf.summary.file writer. This writes out the computation graph for this program to a directory called simple math, which is under our current working directory. Remember to close the writer once you're done with it. Once you've written out the summaries, you can use the ML library from the Google Data Lab namespace in order to run TensorBoard. Simply call ml.tensorboard.start and pass to it the directory where the TensorBoard events have been written out. When you execute this command, you'll get a link right there in your output to access TensorBoard. Click on that link and it'll open up the web browser to show you the TensorBoard start screen. Click on the Graphs tab and there you'll see a visualization of the simple math program that we implemented in TensorFlow. Here are some of the computation nodes in our graph. The add underscore AB adds A and B, the constants that we initialized. The name of this node is the name that we passed in when we set up this operation. Click on the various nodes. You'll see what the inputs to that nodes are and where the output flows. The view pane that you see on the top right gives you the detailed information. Attributes of this particular operation, the inputs and the outputs. The outputs flow to final sum. The TensorBoard visualization is very cool indeed, and especially when you have massive neural networks set up within your TensorFlow computation graph, this is a very useful debugging and monitoring tool. In this lecture, you saw in practice the two phases of a TensorFlow program: building up the computation graph and then executing it using a session variable.